Hello everyone. Today I'm going to explain about the material and energy balance over a single effect evaporator. So first we'll consider the evaporator for our simplification. So feed entering, vapor leaving, and the thick liquor, that is our solute. So first for material and energy balance we will do as overall material balance. In overall material balance, there is total material entering into the evaporator is equals to total material leaving the evaporator. It is the mass entering, vapor leaving, and the thick liquor solution. That is MF is equals to MV minus MS. We will consider it as the first equation. After that, we have to do the material balance of the solute. That is mass of the feed into mole fraction of the feed is equals to mass of the vapor into mole fraction of the vapor plus mass of the thick liquor. S is here the thick liquor solution. We are indicating it with S. So mass of thick liquor into mole fraction of the thick liquor solution. So there is no solute in the vapor, so we are considering it as the 0. So MF XF is equals to MS XS. It is our second equation, that is our material balance of the solute. So let lambda S be the latent heat of condensation of steam at its saturation temperature. The saturation temperature is nothing but the at which the solution boils and when it converts into the vapor. So it is called as saturation temperature. So here we are, lambda S is nothing but the lambda S is equals to H, it is enthalpy, H S minus H C. That is the specific enthalpy at the saturated steam minus specific enthalpy at its water, that is, or the condensate. So lambda S is nothing but enthalpy of the saturated steam minus enthalpy of the specific enthalpy of the saturated water or the condensate. So then the rate of heat transfer through the heating surface from the steam side. The rate of heat transfer through the steam side is MS and lambda S. Here it is steam and S is also, here it is steam, whereas here it is the thick liquor. So at steam side is equals to mass of the steam and lambda, that is the latent heat of condensation of the steam. So now we will see our enthalpy balance over the evaporator. So heat in feed plus heat in steam is equals to heat in vapor leaving plus heat in the thick liquor. So everything we are considering, see, feed, vapor, and the thick liquor and the steam. So heat in the feed is MF, HF. HF is the heat and MF is the mass. So MS and lambda S, as before only we have considered that, see, heat transfer through the heating surface from the steam side is, that is QS, we are writing as MS and lambda S. Same thing we have written here, heat in steam, it is MS lambda S. And whereas in the vapor, MVHV plus MLHL, this is the thick liquor discharge and V is the vapor. So from equation 1, we are substituting MV is equals to MF minus MS. MS is the thick liquor discharge, so I have written here ML. So MF minus ML. From equation 1, we have written this one. MVHV plus MLHL. So after rewriting the above equation, we have got this equation 3. That is, heat transfer rate on the steam side is equals to heat transfer rate on the liquor side. Okay. So if in case of solution having negligible heat of dilution, that is the enthalpy balance or heat balance, then we can write in terms of the specific heats, that is in our energy balance. So now we are doing the energy balance. We can write in terms of specific heat and temperature of the solution. That is QS is equals to Q. So QS, as we know from the steam side, that is MS lambda S is equals to Q. So Q is the heat rate of heat transfer at the liquor side. So now we are removing H and we are replacing it with the specific heat and with temperature. Now we are replacing specific heat and the temperatures of the solution. So MF is at feed side, specific heat at the feed side, T minus TF, final temperature minus initial temperature at the feed temperature and at the thick liquor temperature, plus this is at the vapor, mf minus ml from equation 1, this one, and lambda v. So ms lambda is equals to mf cpf is at the feed side and at the vapor side. So this is our energy balance equation. So this is our material and energy balance for the single effect evaporator. So I will show you the summary. So this is our evaporator, feed entering, vapor leaving, and thick liquid discharge. This is our heat exchanger. This is the saturated steam and the condensate. Saturated steam ms ts lambda s. So first we have done the overall material balance, that is mf is equals to mp plus P is here the thick liquor and V is the vapor. Then we have done the solute balance. Then we have done the enthalpy balance, then the energy balance. There is negligible, see, in case of the solution having negligible heat of dilution, the enthalpy balance or the heat balance can be written in terms of specific heat and temperature of the solution. That is our energy balance. First we have done overall balance, solute balance, enthalpy balance, and energy balance. So this is the summary.